All right, guys, today we're working on the B part of yesterday's lesson. We're still going to be using our identities today and doing some simplifying. I would say the main difference is yesterday you had all of those matching choices to pick from, so you kind of knew if you were in the right track or done or if it simplified enough. Today, not so much the case. You're just going to have to be simplifying using your identities and whatnot. So, of course, a lot of factoring coming at us this chapter. So let's just practice our factoring again with our trigonometric functions in there. I'm looking at A and I'm like, oh, perfect squares, the easiest factoring. So to get cosine squared, we're going to need cosine times cosine. And to get 1, of course, 1 times 1. Difference of perfect squares, difference, subtraction, our factors, one's positive, one's negative, because if you multiply a positive and a negative, you get a negative. Okay, B, a trinomial, lead coefficient 1. So you just have to play that little kind of magic number game. I need two numbers that multiply to 6 and add to 5. Well, 3 and 2. So we're going to have sine x plus 3, sine of x plus 2. And of course, you can have your factors reversed. You can have the 2 first, and then the 3. C is kind of like letter A, difference of perfect squares again. I love those squares. So to get cotan squared, cotan and cotan. To get secant, of course, secant and secant. And just like letter A, one positive, one negative. And as always, you can have those factors reversed. All right, so today we're simplifying. We're going to be using some factoring, obviously, some multiplication. Yes, there is a little bit of fraction work. We're going to have to make some common denominators towards the end, but I have faith in us, we can do it. So just a little quick tips for some factoring. We're always going to look for that GCF first, greatest common factor, something in common in all of the terms. Two terms, we're going to think about using perfect squares, just like in our warm-up problem. Three terms, of course, like letter B in the warm-up. That's where we're thinking about that little magic number game, something that multiplies to whatever and adds up to the middle. And we didn't see this in the warm-up, but we'll see one today. You know how to do this. Four terms, of course, we factor by grouping. All right, so read the directions. I know that sounds dumb that I'm telling you to read the directions, but read the directions closely. They are trying to help you. Factor the expression. First word factor, then use your identities to simplify. So going through my factoring steps, first thing I'm looking for, GCF. I see a lot of secant squared here, so I'm going to factor that out. So to get my first term back, we're going to need a tan squared. And of course, 1, don't forget the 1 to hold the place. You want to be able to distribute that out, get your original expression back. Now, then it says use identities. This is an identity. You're going to start seeing more of those Pythagorean identities this chapter, of course. As soon as I saw the squareds, I was already thinking Pythagorean. It's on the back of your identity sheet towards the top. Tangent squared, I'm just going to copy it down off the sheet, is secant squared. So what I'm writing is in green is what I'm getting off your green identity sheets. All right, and then of course we can simplify this final answer, secant squared, secant squared. I'm going to make it secant, do the fourth. Got it. B. I know it's tempting to look at B and want to try to eliminate some cosecants or some 1s or something like that. We can't due to the subtraction. So again, follow the directions. Factor, factor, factor. Perfect squares, my friends. Let's factor that out. To get cosecant squared, cosecant, cosecant. To get 1, of course, 1 and 1. And just like the warm-up, 1 positive, 1 negative. I'm just rewriting the denominator. I'm just filling it in. And now you can see we have the exact same factor and the exact same factor. They just cancel each other out. Fancy form of 1. So my final answer, cosecant of x plus 1. So I didn't have to really use any identities on this problem, but we did have to use, of course, our factoring skills. All right, let's factor this one. Now, trinomial, lead coefficient 1. So you're doing the number game. Yes, it's out of order, and you could reorder it if you want. I'm just going to leave it as it is and try to get it factored. So I'm looking at that 1, of course, 1 times 1, sine to the 4th, sine squared, sine squared. The question is, of course, the positives and negatives in the middle of your factors. Positive, negative, 1 of each. Where do we do it? Well, we got to multiply to 1, add to negative 2. So we're going to have negative and negative. Because if I FOIL this out, I'd have 1 minus sine squared, minus sine squared. There's minus 2 sine squareds, and then plus sine to the 4th. Got it. Now we're going to use our identity. So anything I write in green is off your identity sheet. 1 minus sine squared is on Pythagorean identities. It is cosine squared. And I'm going to write the same thing, of course, for this one. 1 minus sine squared is also cosine squared. And cosine squared times cosine squared, let's just simplify that to cosine to the fourth. All right, D, more factoring, two terms. So right away I'm thinking perfect squares. We do have perfect squares. To get sine to the fourth, sine squared. To get cosine to the fourth, we know the signs now, 1 plus 1 minus. And then my second factor, I'm going to have sine squared minus. Now I'm looking for identities, lots of squareds. We're looking at our Pythagoreans. Sine squared plus cosine squared is an identity. That's equivalent to 1. So again, anything I write in green is off the identity sheet. And clearly multiplying by 1 isn't really going to change or affect anything. So I'm just going to put my final answer as sine squared minus cosine squared. Got it. All right, one last factoring. So here we go, 4 terms. We're going to factor by grouping. We did not see this in the warm-up problems, but we know how to factor by grouping. On the front 2 terms, they each have 2 secants, so I'm going to pull that out. So I need 1 more secant and then a 1 to hold the place. Now, the back 2 terms, I'm going to take a -1 out, so that way I can change the signs here. Because if I don't use -1, the signs in my parentheses won't match, and that will be a problem for me. So, final factors. One of the factors is your matching set of parentheses, so I don't care which one of these we fill in. I'm going to do the first one. This is my secant x minus 1. And then the other factor are your GCFs, which was secant squared, and then the -1. So I did the factoring. Now I'm looking for identities. And of course the squared, secant squared minus 1, I'm thinking Pythagorean. It is on the Pythagorean identities, tangent squared. Got it. And then of course I still have my secant minus 1 here. No other identities in this. You're welcome to distribute the tan squared or leave it. I'm just going to leave it for now. Why make it any more complicated than it has to be? So factor, use the directions. Factor, look for identities. Okay, next up, perform the multiplication. So we're going to multiply now, and then we will look for the identities. So 1 plus tan of x squared means we really have 2 of these. So I'm going to FOIL it out, of course. I'm going to do the full FOIL, 1 times 1. We're going to have plus a tan plus a tan. Let's combine it to 2. And then tan times tan, tan squared. Okay, so I did the identity, the foiling. Now I'm looking for my identities. So I see the squared, tangent squared, so I'm thinking Pythagorean. If you look on your Pythagorean identities, there is a tangent squared plus 1. Now don't let it throw you off that the 1 and the tangent squared aren't right next to each other. The order you add in doesn't matter. I could totally rearrange it. It should jump out to tangent squared plus 1 off our identity sheet. We're going to replace that with secant squared. And of course, I still have the 2 tan. Got it. All right, B, same deal. We're going to multiply first. This time you do have conjugates, so those middle terms will cancel, so it will save you a little bit of work. So I'm just going to do the 5 and 5. I'm going to skip the middles. I know those will cancel, and we'll do the last ones. -5, 5, and sine times sine, sine squared. Now, none of our identities have 25, and if you look on the sheet clearly, 25, greatest common factor, I'm going to pull the 25 out. Oh, all right, now we've got some identities. 1 minus sine squared is a Pythagorean identity. Look on your Pythagoreans on the back of your sheet. It is cosine squared. And then, of course, we have the 25 still in the front. Don't forget about that. Got it. All right. Moving on, we are into the fraction problems now. 4 fractions. Perform the addition or subtraction and use identities to simplify. Hint, make common denominators. Whenever we add or subtract fractions, we make common denominators. Now, if you look at these, here's a pro tip for you, and you're like, oh my gosh, I don't know what the denominators should be. A common denominator. Use both expressions. So the left has secant plus 1, so I'm going to go ahead and put it on the right. Maybe if I could write it correct here. Here we go. Secant, let's write and talk. Secant plus 1. And I have to notice put that on the top and bottom. Because secant plus 1 over secant plus 1 is a fancy form of 1. I'm not changing the value of the fraction. I'm simply changing the look. My second fraction has secant minus 1. So I'm going to put that on the first one. Again, in the top and bottom to balance. And it's a blue. What I wrote in blue is a fancy form of 1. It just changes the look, not the value. Now, order of operations. We've got multiplication, subtraction, and multiplication. We're going to multiply first. So secant of x minus 1 times 1. Well, that's easy enough. The denominators I'm going to FOIL out. Notice they're conjugates, so the middles will drop. I'll have secant squared, negative 1 times 1. I'm going to multiply over here, 1 times secant plus 1. Again, multiplying by 1, pretty easy. And, of course, when we FOIL the denominators, same thing. The middle terms are going to cancel. So I'm going to take a look. We should have common denominators now. We do. That was the overall goal. Once you have a common denominator, you can fill that in. And we can add or subtract any like terms in the numerator. So I see there's a secant minus secant. Well, that's going to cancel out. Secant minus secant, I'm not going to bother with it. Then I see I have a negative 1 minus 1. Negative 1 minus 1, negative 2. So I did the fraction work. Then it says use identities to simplify. So of course I'm looking at this with the squared. I'm like, ooh, notice I'm circling it in green. Identity. Secant squared minus 1 in the identity sheet is tangent squared. And I'm just going to leave the negative 2, of course. I can still make this a little simpler because if you remember on your green identity sheet on the front, 1 over tangent is cotan. So what I'm going to do is I'm going to leave my negative 2, of course. Think of this, if it helps, 1 times 1 over. 1 over tan, cotan, but I'm going to have to put a squared on mine. Got it. So write it as simple as you possibly can. You want to simplify as much as possible. All right, one more fraction. This time we're adding, same thing. You can't get crazy and cross off those tangents or the 1 plus secant because we're adding. If it was multiplication, I could, but we're adding. We need a common denominator. So I see the right fraction has tan, so I'm going to put that on the left. And then just like the last problem, I see the left fraction, denominator is 1 plus secant. I'm going to put that one on the right. So now we'll have matching denominators. We're going to go through, of course, order of operations. We're going to multiply before we add. So let's do our multiplications. Tangent times tangent. Now, I don't care on the denominators if you distribute. Nothing's going to simplify or really cancel, so I'm just going to leave it. I only FOILed out the last ones because they were conjugates. I was like, oh, that'll be nice and easy. I know some things will drop. I won't have as much to write. This is going to kind of stink on the top because we're going to have to do a full FOIL. 1 times 1 plus the secant plus the secant. And then secant times secant. Secant squared. Same thing in the denominator. I'm just going to go ahead and fill it in. I've got my tan and then the 1 plus secant. If you want to distribute, like I said, you sure can. What I care about, of course, is that they're matching. So I've got my common denominator. I'm going to fill that in. And we can combine now any like terms in our numerators. There aren't any like terms in the numerators, but identities. So tangent squared plus 1 is on your green Pythagorean identities. Tangent squared plus 1, I'm just going to jot it above, is secant squared. Now I can combine my like terms. Secant squared, 2 secant squareds. And I still, of course, have this guy who doesn't have any other like terms, 2 secant. Now I feel like we got a lot of secants and 2's in the numerators, so let's try to factor a GCF out of there so we can try to simplify this even more. So I'm going to take a 2 and a secant out of the top. So I'm going to need secant and a 1 to hold the place. All right, we're making progress. See, it doesn't seem like it. Should have told you to write small at the beginning of this problem. Okay, secant plus 1, 1 plus secant, same thing. Hasta la vista. Now, I'm looking at this to see if I can write it even simpler, which we can. I've got the 2. Of course, secant, of course, is really 1 over cosine. So I'm going to make this 2 over cosine. So I wrote it in green because that's off the identity. And then, of course, we've got our tangent, which we know our identity for tangent. It's sine over cosine. So when I divide by a fraction, we end up multiplying by the reciprocal. So I'm going to go ahead and flip that. So now we can see our cosines cancel. I still have the 2. And I can write this even simpler, because 1 over sine, another identity, 1 over sine, cosecant. So remember, anything I'm writing in green, color-coded here, is off of your green identity sheet. That's why I'm doing that in green, so it kind of matches up. So always try to simplify as much as you possibly can. All right, last 2 fraction problems. Rewrite the expression so it's not in fractional form. So we got to get the fraction out. So again, identities. Cosecant, of course. Cosecant, of course, is 1 over sine. So off the identity sheet, that's why I'm writing it in green. Now you have choices for cotan. I could do 1 over tan or cos over sine. Remember the pro tip. If you're not sure which to use, rewrite everything in terms of sine and cosine. So I'm going to do cosine over sine. So that's all off my green identity sheet. Now I'm doing the fraction work. When we divide 2 fractions, we multiply by the reciprocal. So I'm going to flip the bottom. So I'm going to put sine on top, cos on bottom. Clearly the signs cancel out. 1 over cosine, that is an identity. I'm going to write it in green. 1 over cosine, secant. All right, last fraction problem, and of course we got to have a trick for you. So when I look at this one, I'm like, oh geez. So tangent I could do sine over cos, secant I could do 1 over cos. A lot of fraction, seems kind of, I tried it that way, it's very long-winded, it took me forever. Here's another little pro tip, and you'll see why this is going to work out. And there's only like one like this on your homework. So what I'm going to do, I'm going to get creative, and I'm going to use the conjugate of the bottom, meaning I'm going to do tangent minus secant. And of course I have to do that on the top, and you'll see why here in a minute. Okay, so on the top, of course, I've got my 5. Now, you can distribute the 5 through. I'm going to go ahead and distribute 5 tan minus 5 secant. So I'm just doing the multiplying. On the bottom conjugate, so the middle's dropped, so I'm going to have tan times tan, secant, I'm skipping the middle, secant times negative secant. So it may not seem like we're getting anywhere, but we really are. Now, the numerator, I'm just going to fill that in. Let's talk about that denominator. If you look at the denominator, tangent squared minus secant squared is not actually on our sheet. I'm going to jot on the side what I'm looking at on your identity sheet. We have this. So notice our signs are changed. We have positive tangent squared and negative secant squared. So what I'm going to do, I'm just going to switch all the signs here. I'm going to rewrite this identity, -1, negative, and now positive. Now, even though they're in different order, my signs match up. Tangent squared minus secant squared is -1. So I'm going to replace this tangent squared minus secant squared identity with -1. I just got creative and did a little sign switch. Well, guess what? I can pull this right out of a fraction form now, because clearly dividing by -1 just affects the signs. 5 over -1, -5. -5 over -1, +5. We're out of fractions. I know you might be tempted to want to rewrite tangent as like 1 over cotan or sine over cos, but then you're in fractions. Same with secant. You might be tempted to write that secant as 1 over cos. Not saying they're not equivalent, but they're asking you to write them not in fraction form. So that's why I'm not doing that. I don't want any fractions in my answers. So there's one like that. That's the trickiest thing of the day. I have faith you can do it. Have a great day.